Hey everyone. All right, 8th grade math, 8th grade EOG. Let's do it. Problem 1, answer is B. The thing that determines the charge for each necklace has got to be what's outside of the parentheses here, because this negative sign is a really big indicator that everything in here is going to be the startup cost and how much it costs her to make each necklace, right? So 7.5 is going to be, or 750 is going to be how much she charges for each necklace that she sells, okay? Problem 2, car leaving Athens to go to Atlanta. This equation represents the distance after T hours, okay? So the distance, the total distance from Athens to Atlanta is 72, and we can recognize that by the initial value, which is the y-intercept. She's traveling at, or they are traveling at 59 miles per hour to get there. And we know that because 59 is linked directly to the T. So B, which does 59 represent? It represents the speed of the car, okay? I'm gonna try to go fast, there's a lot of work here, okay? Problem 3. Cost of running a YouTube ad is going to be choice C. The ad costs $900 to produce, and $110 each time it's played is what you earn. So this $900 has to represent how much it costs to make the ad, and then you earn $110 for each time it's played. Problem 4, what is true about this function C of t equals 125t plus 95? Well, they're all true, right? So if we're talking about a plumber who gets the house, the house call, meaning just to get out there, is $95. We know that because that's the y-intercept. The plumber charges $125 per hour, which is the number in front of the variable. And the number of hours it takes to do the job is represented by T. That's how long the plumber's gonna be out there, okay? Sorry, I didn't change anything here. Okay, problem 1, we're just gonna solve for X. X is gonna be 13 in this equation, right? You can see my work. Please pause me when you get a second if you have a problem with that question. Problem 2 here is infinite solutions, right? When you have both sides at equal sign being exactly the same, the answer is going to be infinite solutions. Problem 3, solving the equation. This is going to be just the opposite from the last one. This is going to be no solution, right? Because we have 2x plus 3 equals 2x plus 5. Minus 2x on both sides leaves me with the equation 3 equals 5. Well, since 3 does not equal 5, there is no solution to this equation, okay? And then determine the number of solutions here. This is going to be one solution, which is because I have one value, like one answer, like one number, okay? Problem 1, all right, so we got a word problem. School is planning to order t-shirts for the 8th grade class. The cost of it's $150 and each shirt's $35 to produce, okay? So each shirt will cost $35. We know that that's going to be the term with the variable in it, coefficient of 35. $150 is the one-time fee. It only costs to design the shirt one time. You're not determining that more than once, right? It's going to equal $4,000 to purchase the shirts. It's going to be $110, or 110 number of t-shirts is how much they're going to be able to buy, because they only have $4,000 to spend. For problem 2, perimeter is 32. Okay, so the perimeter is 32. We're trying to find the dimensions of the deck in terms of feet. Well, if this side is 2x, so is this side. And if this bottom is 3x plus 6, so is the top. So we're going to add up all of the sides together to equal 32. And then we're going to figure out what x is. Once you figure out what x is from this equation, which is 2, we're going to plug that 2 back in because it says to find the dimensions of the deck, meaning what by what. So when I plug in 2 back into the equation or back into these terms, I'm going to get a 4 by 12, which is the dimensions of the deck. Okay. Alex is selling tickets to the school play. A student ticket's $4 and an adult ticket's $6.50. Alex sells X adult tickets and 12 student tickets. Okay, so they told us how many student tickets they sold. So that's going to be 12 times the $4 that it cost us, and that's going to be added to $6.50. We're going to make this equation C. Now, it didn't say how much money they had to spend or how much he wanted to earn, so we just set up an equation. Okay? Problem 4, okay, it's $53 per ticket, and it costs $245 for the private tour guide. We only have to buy that $245 once, right? Because that's just the one time that it costs for the private tour guide. So we're going to write an equation to visit the aquarium, which is this: y equals 53x plus 245. Then it's going to ask us how much does it cost for 55 people to attend. Well, remember, x represented the number of people, so we're going to plug in 55 there and solve. It's going to cost them $30,160. Okay, problem 1. We got a couple of properties here that we're going to do. Basically, the properties are real simple. Whatever you did to solve the equation is the property, right? So here we distributed, then we subtracted from both sides, and then we added from one side to the other, and we divided, right? So the properties are very, very, very simple. They're all properties of equality, because remember, what you do to one side, you must do to the other, and that is the definition of equality. Okay, problem 2, the other way around here, it's giving us the reason. Basically, just tell us what to do to solve it, okay? Okay, problem 3, what justifies Emily's first step? Well, the first step was from here to here, and it looked like she added 9 to both sides, which is the addition property of equality, okay? And then which step was used incorrectly? The distributive property. Aaron did not distribute the 4 to the -1, because this should be a -4 here, and he did not do that. So he did not correctly do the distributive property. Okay, problem 1. All right. He has at most $10 to spend. Okay, this is an inequality. He has at most $10, which means it's a less than or equal to sign. Setting up the equation for all of the things he's buying, the soda, the candy bar, and the bananas. We're going to set up an equation, or an inequality rather, and then we're going to solve for that, which means he can buy. Now, this is interesting. He has, hopefully you can see that. He has, X is less than or equal to 675 or 674, right? So the problem with that is we have to be really, really careful. You can't buy 0.74 of a banana. So, and you can't buy 7 bananas because you don't have enough. So you have to round down to the $6 or the 6 bananas, right? You can't go any further than that, okay? Problem 2, okay, 8th grade class. The park permit is $250. Attending the picnic is 75 cents, and each guest pays $1.25. If 200 8th grade students attend a picnic, what inequality can be used to determine the number of guests? Okay, well, we have 75 cents for an 8th grader, and there's 200 of them. So we're going to have that 75 cents next to that 200. Okay, it's going to be plus 125x because each guest pays 125. They're separate from the 75 cents that an 8th grader pays. And that is going to be greater than or equal to 250, which means he can pick 80 guests. Now, we knew 80 guests had to be an answer because it's the only thing over here. And it's going to be greater than or equal to 250 because we want to know how much it's needed or how many guests is needed to cover the cost of the parking permit. Well, that means I can get more guests, right? I can always have more guests because that means I should have more money. So it's going to be that value there for the greater than or equal sign. Okay. Okay. Jason's part-time job saves him $155 per week. He already saved 75. Okay, so $155 per week, which is X, plus the 75 he already saved. Solve and set up an inequality, and it's going to be X is greater than or equal to 2.74. The problem is that he wants to know how many weeks does he need to work in order to get that PlayStation 5. Well, I can't work 2.74 of a week, so I'm going to have to round that up to 3 weeks, which is the value here. So the answer is going to be 3. So be careful on your inequalities, guys. Okay, just because you have an answer from the inequality doesn't mean that answer sits well with the context of the problem. 2.74 here was the answer, but that doesn't make sense in terms of weeks, right? I needed to round it up to a whole number. Problem 4, ice cream shop. We've got ice cream cones and milkshakes. We have a cost for each, okay? Demand has $19 to spend on ice cream cones and shakes. He only has $19. He doesn't have any more than that. So that's an indicator that we need a less than or equal to sign. We're going to set up that value. Sorry, excuse me. And he bought 5 ice cream cones. So we know the 5 times the 150 is going to be the value there. Ready? All right. Again, we're going to have some properties here, and they're literally the same properties to solve for these things. We're just going to see a little difference of a term here. Instead of equality, it's inequality, which obviously these are. Okay, so go ahead and take a look at that. Make sure you got that right. Okay. What did Alex do here? What was the first step? And the first step was the distributed property, right? They were 3 times these 2 values, and then we have that distributed. Okay. Problem 4. What they did was they distributed, which is fine, but then we want to know what happened from 2 to 3, and incorrectly, he was supposed to subtract 3x on both sides. This should be a 2x, right? But he added them, which is not how we work that out. So he did not correctly do the subtraction property of inequality. Okay. All right, formula, we're going to rearrange this formula. This is called a literal equation. So we have V equals pi r squared h, which is the volume of a cylinder. Okay. We want to solve for h, meaning we want to get h by itself. Basically, our process is this. What's next to the h? When we have a pi and an r squared, they're all being multiplied together, which means that I can unlink them by division. So when I divide a pi and an r squared on both sides, I'll have the value of v over pi r squared equals h, which is choice D. Okay. Similar here for perimeter. There's a couple of ways you could have done this one. This one's the easiest though. If I'm trying to solve for w, don't distribute the 2 because that's going to make more of a mess. We want to make less of a mess. We want to clean up the mess. So my first step here was to divide by 2 on both sides, right? And that's going to make it a lot easier for us to solve. Divide by 2 on both sides, and then subtract L on both sides. And this is the value here. Okay. Another process of solving a couple of literal equations here. I equals PRT. And then what Michael did was he subtracted what looks like P and T from both sides. We are not allowed to subtract because these are linked by multiplication. So we have to unlink them using division. So this is the proper value here. Okay, so then we have problem 4. Let's work it out here. The volume formula of a cone is this. We're going to solve here for R. Now to do that, I'm going to have to multiply by 3 on both sides first because that's how I get rid of that pesky fraction. And then once I multiply by 3 on both sides, you can see my work. Then I'm able to unlink with division, the pi and the h on both sides. But now the last step here is because I'm solving for r and not r squared, I'm going to have to square root both sides. So when I square root both sides, my final answer will be on the bottom of the circle. All right. Run on the track team is training for a 1,000-meter race. Okay. So graph the runner's height, average pace as a coordinate grid on the right. Okay. So 215 meters per minute. At 0, 0, they weren't running, right? So at 1 minute, they went up 215. So this is not going to be a perfect graph, but this is a proportional graph, right? And the constant proportionality or the slope is 215. So that should be your graph there. I'm not going to hate if it's a little bit off. Okay, here's the graph representing number of gallons and cost of gas in dollars. What statement can be true? The only one that makes sense is D. If 0 gallons of gas were purchased, 0 miles were driven, right? So if I didn't buy any gas, I have 0 cost and 0 miles driven. I don't know, right? Let's see the other ones. If 10 gallons of gas were purchased, $35 was paid. So 10 gallons of gas, $35. No, that's not even the number that works. For every gallon of gas purchased, $3.75 was paid. All right, well, so it looks like here I got $7.50. I guess that could make sense. I didn't really look at that so much. So B could be an answer. We don't know for sure. Like we can't tell. For every 2 gallons of gas purchased, $5 was paid. That's clearly not true. So miles driven, this is interesting. I don't really know how many miles were driven, so I'm going to go back on this, right? So I can't make sense of the justification of miles driven. It doesn't say anywhere about miles driven. Let's go ahead and select B there, all right? So that might be a better answer. Interesting. I don't usually catch that. Okay. All right, Max purchased a box of green tea mints. 3 mints contains 10 calories. Okay, so we have a equation here where C equals 10 over 3x. So what I'm going to do here is I'm going to go... for every 10 units I go up, I'm going to go over 3 units, right? Now, each full box of mints, and I'm going to continue that process, obviously, here. Each box of mints contains 180 calories. Create and solve an equation to determine the number of mints in the box. All right, this is supposed to be mints, not mins, okay? So basically, I have 180 calories, and that's going to equal my function here of 10 over 3x. We're going to multiply by the reciprocal on both sides, and the reciprocal is 3 over 10. And I'm going to end up getting 54 mints as my final answer there. Okay? All right. What would the value be for x, or what could a value be for x that would make it not a function? Basically, functions have all different x values. So if I want this to be not a function, I'm just going to re-choose or choose one of these x values again. Because if I had a -1 or a 2 here, that would not be a function because the x values would repeat. Okay? So we got a table here representing x and y. What statement is true about the relation? Okay, this is also a function because all the x values are different. So because each x value is paired with exactly one y value, the relation is a function. That's true. The y values cannot be paired with one x value. It doesn't work like that. It's only forward thinking, right? So it's going to be for every x value, it has to be paired with one y value. So B is the only answer that works here. Okay, problem 3. Decide what relation is a function. A is not a function because I have a -1 that repeats. B is a function because the -2, the 0, and the 4 are all different. Hold on, let me get the dog. Come on, Pop. Sorry, he was being a mess. I want to make sure he doesn't start barking. All right. Problem 4, circle all the representations that are not functions. This is not a function. It fails the vertical line test. Remember, the vertical line test is when we draw a line down the middle of any function or any graph, and if that line touches that function twice, or that graph twice, it's not a function. This is all about twice. That can't happen. This is a function. I got -2, -8, and 9. This table is a function, all the x values are different. And then this representation is not a function because that 4 is going to all 3 of these values. And remember that the left-hand side is x and the right-hand side is y. These are not functions because the x values repeat. Okay, what situation accurately represents the graph is the only one's A. A student rides a skateboard to another friend's house. Okay, so this is time and distance from home. So as we're going up here, he's getting further and further away. I guess these are in miles, right? So 1 mile, 2 miles, and 3 miles away from his house. So he's riding a skateboard to another friend's house. After 30 minutes, so 30 minutes pass from 20 to 50. So that checks out because this horizontal line is 30 minutes. He leaves and walks to the store. Okay, so we have to assume the store is further from the home than his friend's house, but it doesn't say that, which is fine. So A is going to work. So problem 2, 10-kilometer race, and this is going to be distance and speed. Okay, so where was Diego when he was going the slowest? He was going the slowest between points 2 and point 3. And we know that because his speed went from 11 kilometers per hour to about, what, maybe 9.5? And that is going to be the biggest drop or the lowest value of his speed. He doesn't go 9.5 kilometers per hour again in this entire race, okay? Okay, all right, so we've got time in hours after 8 p.m. and temperature, okay? So this value here at 0 is 8 p.m. And then 1 hour is 9 p.m. And you can see it gets colder as the night goes on. And then at about, maybe 4 o'clock in the morning, it starts to warm up a little bit, right? And usually when sunrise happens in some places, right? So it's spring. So here's a scenario. So it's springtime, and it was 60 degrees at 8 p.m. And we know that because it's certainly not summer, right? It's usually not 60 degrees. It's summertime. It's in the dead of summer. And at 8 p.m., then overnight, it dropped to 45 degrees, which is true. And then it started to warm up to 65 degrees by 8 a.m., right? Which is back up here. Okay. Elena filled the tub. So which graph represents the context? So the water level in the tub is represented well, and the reason because the water level goes up, we can say this is height of the water at the tub. And then it stays there, which is why, the bathtub, she probably put the plunger in there or the stopper in there to stop the water from coming out, and then she emptied it out. Right? Okay, problem 1, student council, t-shirts sold, domain. Now we have to assume that wherever the graph ends is where this begins, right? So where the graph starts, it's where it starts. So we're going to say the domain is 10, which looks like 10 here. Remember, domain is x values. 10, and it's going to go to about 90, 85-ish, right? Actually, this is 100. This is probably 90. Sorry. If you put 85, it's fine. So it's going to be all-inclusive, which means brackets, hard brackets. We have to assume because the line stops at a certain point that it's going to have a value there. Right? There's no open circle is what I'm trying to say. So we don't know if that's parentheses or not. So we have to put a hard bracket. And then it's going to represent t-shirts sold because that's what X says. And then the range of this is going to be 50 to 350, which is the profit, which is what the Y value says. Again, all-inclusive, which means hard brackets. There's no open circles to indicate anything else. Okay. So we got a Bank of America student taking an elevator. Describe domain and range. D, which is the domain, which is X, stands for the seconds. And the time in the elevator is from 0 seconds to 8 seconds. All inclusive again, because she does get to actually the 8-second mark. Range is going to be from 0 to 12, not 12 to 0. Range doesn't work like that, right? Remember, we're always going to work with characteristics that go from the lowest value to the highest value. So range is going to be from the lowest value of 0 to the highest value of 12. Okay? Again, all inclusive, because there's no open circles there. Okay? Quality control manager at Garnier, shampoo bottles, which is the following is true. The domain is 0 to 40. Remember now, domain is X value, so be careful because milestones in the past have put a Y here. And domain is not Y, so just be careful of that. So domain is 0 to 40, and they are going to be hard brackets, which is closed circles, which they are. And that is when the time that it takes to pack a shampoo bottle, which is time. It's the only one that works. Problem 4, describe the domain and range of the context. Okay, well, we've got 0 to infinity, because that arrow means it's infinity, and that represents data in gigabytes, and the X value says that, okay? Range is going to be the cost. Now, the cost of this data starts at $4. It doesn't start at 0. So we're going to have a $4, and again, it's going to go up forever. I realize that it's going to the right forever, but the characteristic says it's going to go up as well. So my range is going to be from 4 to infinity, okay? And that's going to represent the cost. Okay, problem number 1 here. Okay, this is a graph of the linear function, and we have a linear function, and we have another function here. So we have f of x and g of x. Y equals 2x plus 5 is going to represent the linear function because it says that, right? Slope of 2, y-intercept of 5. And then which of the following statements are true? This is the equation of the graph. And what did I put here? This is y equals 2x minus 3. Yeah, sorry about the mess here. Okay, so y equals 2x plus, minus 3. Hello. Okay. C, the rate of change for f of x, which is 2, is greater than the rate of change for g of x. This isn't 2, though. This is just x. Because it's going up by 2, and it's going up by 2, so it's just x. Okay, so this is 2 and this is 1. Can't read my own writing. That's the only one that works here. The y-intercept of f of x is greater than the y-intercept of g of x, which is also true. Okay, problem 2. Function is modeled here, so we have h of x in a linear function and p of x, which is also a linear function. P of x, I went ahead and did negative 2x plus 25, because that is what the value of this says. Okay, compare the rates of change. H of x is 4, which it says, and p of x is negative 2, which it also says. You can use slope form and slope intercept to get your values there. Compare the y-intercept of both. The y-intercept of h of x is negative 8, and the y-intercept of p of x is 25. So I'm not really doing much comparing. Okay. All right, problem 3. Hector has hours and miles of slow bikers. Okay, so we've got h of x, which is 10x. Okay, that represents the distance traveled in miles. And then we have this function s of x, which is another representation. So we've got a linear equation, and we've got a graph. The graph is 2x. Okay, so we've got h of x is 2x, and this other graph is, 10x and 2x. How much faster is Hector than the slow bikers in miles per hour? Well, he's 8 miles per hour faster. Okay, so Hector is this 10x, and he's 8 miles per hour faster, because for every 1 mile that they drive, he drives 10 as opposed to 2. Okay? Last one here, we'll take a little break so I can upload this. Jay and Nathan are completing a race. We've got Jay's race and Nathan's race. Which student ran faster? Jay ran faster because his slope is 6, meaning he's got a steeper slope, which means he goes faster over time. Nathan is 5, and again, we can determine that by looking at the y values. All right, take a quick break. Come back in a minute. All right, let's keep it going. All right, problem 1. What is the slope and y-intercept of the line 2x plus 3y equals 6? Slope is negative 2/3 and the y-intercept is 2. You're going to have to move this around, rearrange it to slope-intercept form from standard form. As you can see, I did my work here to do that. Number 2, given the line, what is the slope and y-intercept? Same idea. We're going to have to change from standard form to slope-intercept form, and we're going to find both of those values there. Problem 3, so this is point-slope form. We're going to have to identify the slope and the y-intercept. We're going to distribute the 1/2 to both of these terms first, and then add 2 to both sides, which is what I did here. And again, we can see the slope and the y-intercept. Okay, linear function is modeled below. Identify the slope and y-intercept. You can see a trend here. This is obviously very important. Right? So the value is, again, by point-slope form, distribute the negative 3, add 10 to both sides. You can see what I did, right? Graph the table below, or given the table below, we're going to find the slope and the y-intercept. So what I did was I wanted to find the slope first, use the slope formula. Slope is 3. You could pretty much determine that as we go along anyway, but I wanted to just do the slope formula. Then we're going to plug the slope and one of these points into the slope-intercept form to find b, the y-intercept. Again, we didn't have to do that. It just made a little bit more sense for me to show that process out. So I used the slope of 3 and the 0.48, right? So x and y. Plugged it into the slope-intercept formula, left b by itself, solved for b, found negative 4 as the y-intercept. Okay, same process here. I've got 2 points on a linear function. Found the same slope, or the same idea of slope-intercept form using the process for problem 1. Okay? Right. Josh's car trip. The only thing that makes sense here is it took him 4 hours to go 160 miles, right? So A says Josh was 160 miles from home when the trip started. Yeah, when the trip started at 0 minutes, he was 160 miles from home. And then the only other one that works is C, Josh traveled 40 miles per hour. It took him 4 hours to go 160 miles. So he went 40 miles in each hour, okay? Problem 4, fence installation. Identify the initial cost. That's easy. The initial cost is the y-intercept, 150. Slope again is 30. We can just go up 30 and, we can go up 30 and go over 1. But I went ahead and went from 150 to, it looks like 225 and to 5, right? So I found out that was 75 over 5. Or how did that work actually? 150 to 5. This is 225. I make a mistake here. So this is 75 over 5. This is going to be 15. It shouldn't be 30. Why did I put 30? Yeah, it should be 15. Oops. Glad I caught that. Thanks, guys. Okay, moving along. Okay, problem 1. Piggy bank, time in weeks, amount of money. So it looks like Mia started with $30. And she saves $5 every week. Okay, so I went up $5 and over 1, which is the case here. Bad graph, sorry. Drew's scuba tank, how much air did he start in the tank? Started with 40 cubic feet. And then describe the rate of change. So it looks like it's going down 20 cubic feet of air every 3 minutes. So that's going to be negative 20 over 3. That doesn't simplify nice, so I just left it as an improper fraction. Okay. Robin's class is donating money. How much money was in the original donation? So we don't have a y-intercept here, but I'm going to have to figure that out. So I wanted to find the slope, and it looks like I'm going up $45 every 3 days. This is wrong. So $45 every 3 days, right? So that looks like it's going to be $15 a day, right, per day. So then if I went back to 1, I don't know why I did this, right? So if it's going to be $15 per day, I'm going back 2 days. This is $350. Hello. I think I got ahead of myself. I was kind of going too fast, right? So $350 was the original donation. $15 per day is how it goes because I'm not going up by 1. Okay. Problem 4. Friends at a skating rink. So how much was the admission fee? The admission fee is going to be looks like $50, right? So what am I going up by here? So every 2 days, I'm going up by $24. Okay. So if I went back, and so it's $12 a day. So I'm going to go back $3 or 3 days. Okay, so it's 36. So this is going to be $50 admission fee, which is correct, and then it's $12 each. Okay. I did one right. Great. Problem, I was just trying to go too fast, probably. All right, what is the equation of the line of best fit? Well, a good equation of line of best fit was if this continues, I'm thinking about 110, which is a y-intercept. And it looks like it's going down by every 10, it goes over 10. Right, so down 10, right 10. So that's -1 is slope. Okay, problem 2. Only one that makes sense is it has to be a positive slope with a positive y-intercept. So it's going to be either A or C. This doesn't go up. It doesn't appear to be going up by 1 every time because look at the scale. This is a big 5 and this is a small 5. So it looks like it's really going up by a bigger slope of 1. So it's going to be a 2. Right? So I went ahead and picked choice C for that. Same idea here. What would be a line of best fit? I know I need a negative slope with a positive y-intercept. I didn't choose the -2 because this is a lot more convenient. Like it's 1 and 1, they look like the same distance. 2 and 2 looks the same distance. So I went ahead and did a 1/2, like down 1, right 2, down 1, right 2. It looked a little bit more accurate to me. Okay, problem 4, same idea. What equation could be the line of best fit? Looks like I could start from 10. I don't know if I like up 10 over 1, up 10 over 1. Yeah, because of 10, up 1 over 1. Yeah, I don't like D. I like A. I like A. The slope, see, the scale factor is up by 10 and over 1. I don't know if I like that so much. All right, moving along. All right, problem 1. What could represent which statement best interprets the slope of the line of best fit here? Okay, so this is hours spent studying and score on a final exam. Okay, so C is the best option. Student exam scores increase 5 points per hour of studying. Okay, let's see. Well, without any studying, it looks like they get a little bit over a 50. If I studied 1 hour, if I studied 2 hours, I went up 10 points about. Right, so it looks like I'm going up 10 over 2. Right, so it's about 5 points per hour of studying because this is hours of studying. Okay. Question number 2. Which of the following is the most reasonable equation for the line of best fit? Well, okay, so we know we cannot have a -8 because that's a positive 8 in the y-axis. We know we can't have a negative slope. So, okay, so it can't be A and it can't be C. I do like the 3 over 4. So up 3, right 4, up 3, right 4. Because again, the scale on the y is not really accurate to, or not really congruent to the scale on the x. Okay. All right, scatter plot below. Determine the y-intercept and describe what it means in the context. Well, the y-intercept is about 80. I think I put 79. Well, oh, it is 79 because we have an equation. Hello. All right, so 79 and describe what it means in the context of the situation. So that means with no hours of exercise per week. So 0 hours, your resting heart rate is 79 beats per minute. Okay. Here, determine the y-intercept and describe what it means in the context of the situation. Again, the y-intercept is 70, right? So it's clear here. And then what does it mean in the situation? It means at 0 degrees Fahrenheit, I've sold 70 hot cocos, right? So when it's really super cold, I sell a lot of hot cocoa, which makes sense. Okay. All right, frosty caboose, track temperature of the ice cream sale. Okay, great. All right, so if the manager draws a line as fit, estimate the y-intercept. Okay, the y-intercept looks like 110. This graph is the same from a couple graphs ago. So it's 110, and then when it's 0 degrees Fahrenheit outside, they sell 110 ice cream cones. Now, I don't know if that makes a whole lot of sense to me. Because when it's cold out, the last thing I want is ice cream. Right, so I don't know how that makes a lot of sense, but that's the context of the situation. Yeah. Problem 2, what is the best interpretation and meaning of the y-intercept? Y-intercept is probably 20,000. Certainly not 10,000. It's not going to go down that far. okay? And definitely not 42,000. So C is the only one that works, and that's the starting salary of the company. Okay. 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 Describe the situation with, again, looks like ice cream. Okay. So Brewster's. So describe what the slope means. Okay. Now I just chose a point in the beginning and a point at the end and did the slope formula. So it looks like for every about 31 degrees, 31 is the slope. So it went up 31 over 1, about, if I did the slope formula right. So which means for every increase of 1 degree Celsius, total sales go up by $31, which is about right, okay? Okay, Coach Sloan, what's the best interpretation and meaning of the slope in context? Okay, the number of points increases by 2 each for each minute of play time. Okay, well that makes sense. So if I'm trying to find the slope, again, I chose a point on the left-hand side and I chose a point on the right-hand side, estimated the best I can. So the number of points increases by 2 for each minute of playing time. Okay. All right. Based on line of best fit, how much money can you expect to earn with 8 years experience? All right, well, 8 years experience, I'm gonna go up here and it's about $100,000, okay? How many tomatoes can be expected after 7 hours of sunlight? So 7 hours of sunlight. We're going to estimate it here. It's about 18. All right, it's not perfect, but it's about 18. Again, line of best fit is going to help us with that a lot. Okay. How many hot cocos can you expect to sell with a temperature of 40 degrees? If I continue the line, which I really drew a bad line, 40 degrees, maybe 30, 29, anything about there is fine. Problem 4. What is the average number of hours of sleep per day if a person has 25 treats per week? It's about 2. So 25 treats per week. Continuing the line, it's about 2 treats per week. Okay. Alrighty. Right back. All right, everyone. Final piece of the puzzle here. Okay. Given 3 to the second power times 3 to the negative 5th power, the rule is we will add together the exponent number. So this is going to be 3 to the negative 3rd power. However, we want to continue to simplify this as best as possible. This is going to turn into 1 over 3 to the 3rd power, which is here. Now, interestingly enough, I circled C, which is the answer here, but 3 to the 3rd power, 3 times 3 times 3 is 27. So we'll go with D instead, because that's more simplified. That's a more acceptable answer, okay? Problem 2, what is the mistake? Well, the mistake Hugo made was he divided the exponent numbers, and that's not the rule. The rule is we subtract the exponent numbers, so the answer should be 3 to the 7th power, okay? Moving on. All right, select all the expressions that are equivalent to 4 to the negative 3rd. Well, we know the 4 to the negative 3rd is 1 over 4 to the 3rd, so C is a choice. 1 over 64 is also a choice here. It doesn't say that, but that's going to be 1/4 times 1/4 times 1/4, because that's 1 to over 4 to the 3rd power. And also enough, when we evaluate this, we get 1 over 64, right? Well, B is also a choice, because 2 to the negative 6th is going to be 1 over 2 to the 6th power, which is 1 over 64 as well, right? So the other choices aren't going to work. Those are the 3 that do. Problem 4, our answer is going to be 10 to the 3rd power. We're dividing, because it says how many times bigger or how many times smaller is another value. So we're going to do 10 to the 5th divided by 10 to the 2nd power, subtract the exponents, 10 to the 3rd is my answer. Okay. How many times larger? Well, again, how many times larger? We're going to go ahead with a division problem. So when we divide these two problems together, it wants to know how many times, so it doesn't want that in scientific notation so much. So it's going to be about 23 1/3 times larger. Okay? Problem 2, estimate how many times larger. Again, we're going to be dividing when it asks for that process. We're going to divide, put that in the calculator. Desmos calculator will do that for us, right? So we can do 3 times 10 to the 11th power. The other thing you could do here is you could take these numbers and put them into just standard notation, which is just like taking it out of scientific notation, divide them, and then go backwards from there. Okay? Our problem 3, again, how many times the number of stars in the galaxy is the stars of the universe. We're going to divide these values. Okay? Again, how many times larger? We're dividing. So you see a common pattern here. Scientific notation, we're going to add. You can put that in the calculator and I'll do it for you. Or again, what I like to do sometimes is I will just take these numbers out of scientific notation, put them in standard notation, and then add them or subtract them, and then put them back into scientific notation. Same with these two here. How many bucket loads? There's some information here that's not super necessary. We just want to make sure we find out how many bucket loads it takes to take out the world's oceans, which is a significant amount, if you did not believe that. Okay, same process here. More dividing, again, calculator or put it into standard notation. Another problem here. Same thing. What's the difference? So it says, what's the difference we're subtracting? Okay, times, how many times bigger or how many times smaller is division? What's the difference is subtraction. Okay, all right, so traveling out of town, visit the trampoline park twice. Which park or which plan would she choose? You choose option A because option A is cheaper. And then how many times are they gonna go to the month? And that's gonna be option B. Or you too. So this is gonna be how many times larger, which is where Jen chooses option B. Problem 2, purchase 20 concert tickets for a total of $225. The concert tickets cost $15 for adults and 10 for children under 12. How many tickets for children under 12 did Mr. Johnson purchase? We're gonna set up this equation here, A plus C equals 20, and then 15A plus 10C equals 225. So we're working with systems of equations here, right? So then we're going to substitute our first equation, the A plus C equals 20. I reordered it to solve for C so we could easily plug it in. We solved and we got C is 15 because we wanted to know how many tickets for children. So they purchased 15 tickets. Okay, more systems problems. We have two values here, two equations here. We solved for one of them to plug it in. Again, same here. See, it's fun. Okay, another problem here. Andre's savings, what is the intersection point? Okay, so we have two values here. We have two equations, y equals 7.5x plus 2.5, y equals 5x plus 15. Intersection point, we could use Desmos graphing for that. So whenever you have a graphing problem or whenever you have a systems problem, just use Desmos graphing calculator. It's gonna be your best bet, okay? And then what does the point mean? We know that X values represent time and the Y value represents the money saved or the money. So it's gonna be 5 weeks, $40, okay? Write a second equation or draw a second equation here. That would be inconsistent. Inconsistent means no solution, right? So no solution means they're parallel lines. So all I had to do was make sure I found the slope of this first line and then continued it on. Okay. Use substitution to find this. We could also understand what the equation of the line is by finding the y-intercept and then doing rise and run. Okay, so you can see that I put down both equations there and we're good. The solution to a system of equations is 5, negative 19. I'm plugging in 5 for x and negative 19 for y, and I'm seeing which value or which statement is true. So once I find which equation is true, I can just go ahead and circle my answers there, okay? So there's only 2 of them that have that value. All right, let's keep it going. That. Okay. Which system of equations matches the graph? This looks similar to the question we just did. Okay, we're just going to go ahead and do that. Given the system below, how many possible solutions are there? None, they're parallel. And how do we know? We know that the slopes are the same with different y-intercepts, which means they must be parallel to each other. Okay. All right, so we have Mitch and Jenna. We're going to graph their lines based on their initial values, which is the cost to rent the shoes, and then how much they pay per game. Okay. Here, I don't know why I didn't graph this. Why didn't I graph this? I don't know why I didn't graph it, but I have my values for bananas and apples. How much of each item did she purchase? Jill bought 2 bananas and 11 apples. I don't know why I didn't graph it. I would graph it, but we're kind of short on time here. All right, given the system below, what could be the result of a possible first step? Okay, so the possible first step would be when I substitute x plus 1 in for the y value on the second equation, which is choice B. Okay. What could be a first step using the elimination method? Well, remember elimination, I'm trying to get opposite values. So I could multiply the first equation, the top equation, by 2, which will give me a positive 10y, which is what I'm looking for to get rid of the 10 and the negative 10. Okay. Popcorn stand, system of equations, 2 equations here, solve for large popcorns, which I don't think I did. Why did I not do that? Let's get back to that. Problem 4, determine the number of action figures and dolls in the store. There are 20 action figures and 50 dolls. I'll go to this other one in a second. Okay. Graph and write an equation in a line that's parallel to the given function.
I showed up on Friday. I'm so slow. It was bad.
No, it's fine. It's fine. You're totally fine.
Wait.
No, you're totally good. All right, the linear equation 4x minus 16y equals negative 16 is graphed below. Hey, showing the problem here. We graph the line. We know that it's going to be parallel because it said graph one is parallel. Okay, problem 2, linear function here. I just needed one that was perpendicular, so I had to find the slope of the black line, and then I could do the negative reciprocal, right? So perpendicular lines have negative reciprocals of each other. Morning, boys. So we're good there. Okay, problem 3 here. What's the equation of a line passing through 2, -1 and parallel to the line represented here? So if I know they have parallel slopes, the slope has to be 2. So it certainly can't be A or B because they have a slope of -1/2. Those would be perpendicular slopes, by the way. And then C and D, the only answer is C. When I plug in my values, I'm gonna get a y-intercept of -5. Okay, kind of the same idea here, but I want it perpendicular. If I know the slope of the line originally is negative or positive 2, my perpendicular slope is -1/2. Good. Okay, so that's that. All right, let's go back to this problem here. Okay, I sold a total of 138 small and large popcorns. So small plus large equals 138. That's my first equation. Second equation is what are the values of these. So it's $2.50 for a small popcorn and $4 for a large, and that adds to equal 466.50. Okay, I went ahead and subtracted L on both sides so I could solve for S, which I then plugged in here. Apparently, I didn't feel like it was necessary to solve this equation. So we have -2.5 L plus, this is interesting, my phone is my calculator. So let me go get a calculator, hold on. Hold, please. I'm back. Okay. 2.5 times 138, 345 plus 4L equals 466.50. Let's combine like terms. So it's going to be 1.5L equals 466.50 minus 345. Oop, 466. This calculator is broken. 345 is 121.5, and we'll divide by 150 on both sides. 81. So how many large popcorns were sold? 81 large popcorns were sold. All right, guys. Thanks so much. See you.